Morning to everyone. Formally, that was Buddy Holly. That'll be the day, and that's the way it pretty well got started way back when. Now, we just did an exercise in class. It was a win-win. You don't lose any points. It's all extra credit. It just goes onto your test score when we do that test. So if you got 1 point, that's 1 point that gets put on. There were 5 total. Now, what you may find is that you think you had all those formulas in your head, and then they scramble. And that's worth knowing. You didn't lose anything in this, but it does suggest how you want to approach a test. So, for example, if I'm taking a test and I'm going to have a lot of time, and you will, for this particular test on formulas, and we aren't ready to do that yet. But what you would do is maybe write the formulas down quickly before they scramble. So you have area, perimeter, volume, and the ones that are really bugging you, put those down quickly so you don't what? So you don't get rattled. Then go ahead and do the problems. So something to learn out of that. And it's a case where the formulas are important just to know as part of a background in mathematics. Whether you're going on to another course or not, just knowing those formulas really is a payoff. Now, the kinds of problems that we do with these formulas fit into 2 categories. The first category would be I give you a rectangle, and I tell you it's 8 by 11. Maybe the size, well, let's say 9 by, what's a good sized bedroom, feet-wise? 9 by what? 9 by 12? Maybe 9 feet by 12 feet for a bedroom. And you want to know how many square feet for carpet. Well, you just multiply 9 times 12, or 9 times, we say 9 12? 9 times 12, which would be 108 square feet. That's a very straightforward problem. Then there is the kind of problem I'm going to have Ernie put on the document cam for me. Now, this is more of the type of thing that you would see maybe where you have a yard. Now, you have a yard, and maybe over here you have a half circle just for maybe a flower bed or something. And then over here, this may be where a garage comes in. And then over here, you may have something that you've created. So your total area here, just in terms of your yard, might be this rectangle, this triangle, and this half circle. So the question, how do we find the area of that shape? And what I'm going to do is block off some things. I'm going to block off this much and realize that that's a half circle. So if I find the area of that whole circle, I just divide by 2. If I move over here and block off that, do you see the triangle? So I can find the area of that triangle. And then I'm going to block 2 separate areas. I'm going to do this, and then do this. And now what do you see? A rectangle, right? Now, we sometimes just draw those little lines in to help you see. But now my question, if this is a rectangle, we just said you take the length times the width for the area of the rectangle. What is the length of this rectangle? I'll try to block off that much so you aren't getting confused. The length of the rectangle. 32, isn't it? Because I have the 12 up here. See, there's a line I could draw right across where the pin is. So I have this 20 and this 12, so that total length is 32 feet. And across the top, it's 20 feet. So sometimes you have to do what we call read the diagram. Now, if we were doing construction, we'd talk about blueprints. And you sometimes have to read the diagram to figure out the dimensions. So what we're going to do is find 3 different areas. I'm going to find the area of the triangle, the area of that half circle, and then the area of the rectangle. Now, another thing you have to be careful about. Sometimes, as we look at the diagram, there are numbers that don't have anything to do with what you're trying to find. If I want the area of this triangle, I don't need the diagonal. Because what is the area formula for a triangle? Somebody? It's a right triangle. Half the base times the height. So I have the base, I have the diagonal. How am I going to find that height? Where am I getting it from? No, be careful. The 12 that was here is the same distance as what? Right here. So the height you get from over here, so the height is 12, the base is 5, and the 13 doesn't come into it as far as the area for that right triangle. So let's take two problems we're going to do here. We're going to find the area of this half circle, the area of this right triangle, and then we'll finish off with the area of the rectangle. And for those of you watching at home as we go to the board, the problem that everybody did just before we started the music, that's why we're a little bit late starting this morning, we did a little in-class quiz. And so what I had people doing, writing the formula for each of these from memory. So I just said that we had a sphere and I wanted the volume. We had a circle, find the circumference. Have a right triangle, find the area. We had a square, find the perimeter. We had a cylinder, find the volume. And those were supposed to be memorized for today. And so if you're watching this at home and you were doing this, I gave about 4 minutes, not too much time, and you could do a self-quiz kind of thing. Remember that we did yesterday where we had a list of formulas for areas, volumes, and perimeters. And you may not, obviously, if you don't have the book, you wouldn't have that. But if you could find these, memorize them, would you have done well? That's the question. Now, the formula I needed, two of these formulas, one is the right triangle, the area. So this one was 1/2 times base times height. We also write that as what? A different way. And I be careful, don't want the square. Just BH over 2. And the B and the H written together mean multiply. So let's go back to our diagram. Our diagram is 5 feet in the base, correct? So this is going to be 1/2. And I'm going to put the dimensions in, 5 feet. That little hash mark stands for feet. If we have a double hash mark, it stands for inches. And then this was 12. Notice I didn't use the 13. Now here I would have 5 feet, and I'll write this one out in a different way. 12 feet, so you can see it either way, and it's over 2. So what would I do at this point? I could take this product and then divide by 2, or I could what? Just cancel. And 6 times 5 is 30 square feet. So this area is 30 square feet, or what's the other way I can write square feet? This one, I don't know if you've seen this, but it sometimes is done. You put the FT with the 2, meaning feet squared. Okay? That's the area of that right triangle. Now what is my formula? Now coming back to here. This is the formula for the area of a circle. What is that? Circle. Okay, circle area. That's a weird way of writing that, but to make a distinction between circumference and area. Okay, is it going to be 2 pi r or is it going to be pi r squared? Why? What is the key? Because you're thinking, if I have 2 pi r, all I have is feet at the end. But if I have pi r squared, I have square feet at the end, and I want area, so it has to be the pi r squared. Again, I know there are 2 formulas. 2 pi r gives me circumference. Area gives me pi r squared. You have to remember that at the end, you want square feet or feet squared. If I had 2 pi r, I'd just have feet, wrong units. That's the key. So we are going to have pi times r squared. Okay? Back to my diagram. What were you given for that circle? Half circle, I might point out. Were you given the radius? What do we call that distance all the way across? This 12 I have here, we have a name for it. The diameter. Okay, so I gave you a diameter of 12 feet. So diameter is 12 feet. That is 2r. So what's r if 2r is 12? R is 6 feet. Half the distance, correct? So you look back at the diagram. One more time, Ernie. 12 feet across, so the radius is 6. Now keep in mind, it's a half circle. It's not the whole circle. Just a half circle. So I'm going to take the area of the circle and divide it by 2. So that's going to be 3.14 times 6 feet times 6 feet over 2. Now, if you brought a calculator with you today, we can use a calculator on this particular test. So 6 times 36 is 36, and we divide that by 2, and we'd have 18 times 3.14. So if you had a calculator, we would simply go ahead, and what I'm going to do is just show the typical kind of calculator that I would recommend for what we're going to do. This is called the 4-function calculator. They are rather inexpensive. They don't do very much, but you'd be amazed at what we can do with this. So in this calculator, we come off there just for a moment, Ernie. I'll try to get it up here so we can read the output without the glare. And I'm going to go ahead and turn it on. Let's see if I can... Where can I put it? So there's where I want it without the glare. This is going to be interesting. Give me a moment to move some things around and see if I can get the calculator. Ernie, this is a no-win situation. What am I going to do here? Okay, as you look at the right, okay, we'll see what we have there. You can see the output better. I'm trying to avoid the glare. If I turn the light, might. I don't know. Let's see. See, I get some... Well, I'm getting the shadow from the camera lens, and that's what seems to be the problem. See if I do that. I don't want it in the shadow. Okay, at any rate, I'm going to put in 3.14. Then I'm going to hit a times key. And then I'm going to multiply by what?
36.
Well, I could do 36 divided by 2. So 36, and I get an equals. And I didn't press hard enough for it to work, so let me try one more time. I'm going to clear. So I'll clear it and see if I can press the keys harder. 3.14 times there. Oh. Finally, it did everything I wanted, but not when I wanted it. 3.14 times. Now I'm going to put the 36, hit an equal key. There, I get 113.04. And divide by 2 and equals, and there's my 56.52. That didn't read as nice and clean as I wanted, but I'm going to put 56.52, and what do I have to do in the board? Call it what? I can't leave it that way. I have to call it, it's the area, but what units? What I was wanting, square feet. You have to indicate what you're measuring. So this was square feet, just like this down here was square feet. So I have square feet here. Now I have square feet here. I've done 2 of the 3. So what I'm going to do is come back to the diagram. Before we do that, Ernie, I have to close off the light or it will completely fade on the television monitor this evening or afternoon. Okay. Now what am I going to calculate? Block this, block this. I've taken care of those, right? And I have left that rectangle, agreed? So the rectangle, I need the area of that. So let me come back to the board. The area of the rectangle. What's my formula? Just the formula now. It has L's in it, W's in it.
L times.
Don't have a height per se. We talk about width and length.
L times L plus W.
L times W.
Okay, is it the 2L plus the 2W, which only would end up with what? Feet? Or is it L times W, which would be feet times feet, which would give you square feet? Which formula? LW, because you want feet squared. Again, my question. I have two formulas that you'll find yourself remembering. One is L times W. The other is 2L plus 2W. This one gives you feet times feet. That's good because area is square feet, feet to the second. If I take 2 times L plus 2 times W, I just get feet plus feet, which gives me feet. So if I know in area I have to have square feet, it helps you remember which formula you're going to use. That's my hope. Okay, back to the diagram. What was the length?
Sorry, 32.
I've heard of 12, I've heard of 20, and I've heard of 32. Remember, you have to add the 12 and the 20, which gets you to 32 feet for the length. So I'm putting a little hash mark there. Then the x. Now what was the width? The 20 feet. Yawning feet.
Sorry.
I'm just giving you a bad time. 32 feet times 20 feet gives you what? I'm waiting. 20 times 32. 640 feet squared, or square feet. So I have this number here. I have the 56. And Ernie, if we just slide just a little bit over, I need to pick up this 30 down. There we go. So I have that 30. Let me walk off camera so you can see the three numbers. We have a 30, a 640, and a 56.52. You have to add all that up to get the total area. So will you add that up for me? I'm going to walk back into the camera view, and I'll do up here, I'll write these down, a 56.52. We said a 30, which technically is 30.00, and I had 640.00. So I'm going to add those up. Does somebody have a number for me?
726.52.
I'm hearing a 726.52. I'm waiting for head bobs to see if you're in agreement with that. Okay, I have 5 of you nodding that you're in agreement. 726.52. Would that be okay, or would you take points off if you were grading the paper? Okay, you could round off, but what's missing? Okay, let's slide over just a little bit, Ernie, so I have enough room to put square feet. Thank you. Now, if you don't put the units at the end, I won't give you full credit, because you need to know whether you have square feet, square inches, square yards. Very typical problem. And it's one of the more difficult problems to do. Now contrast that to the following kind of problem, where I tell you that I have a triangle, a right triangle. So a right triangle and let me tell you that it has a base of 5 feet. It has, I don't want to do that. I'm going to do 4 feet. And I want the height larger. I'm not getting my numbers chosen well. 3 feet for the base, the height of 4 feet, and the diagonal is 5 feet. That's my right triangle. So I've given you the dimensions, the base, the height, and the diagonal. A 3, 4, 5 right triangle. By the way, this satisfies the Pythagorean theorem we did yesterday, where we said 3 squared plus 4 squared is 5 squared. So that means I had a 90-degree angle. But I'm going to ask for this. I want the perimeter. So what would you tell me for this problem? What is your formula for perimeter? You're going to take a walk around a triangle. So what are you going to add together? Okay, the base plus, I'm proud of you. We got a plus this time. And the height. And then add in the diagonal. That's your formula. Now substitution. Next step. I want to see in the next step your substitution. So we have 3 feet plus 4 feet plus 5 feet.
12.
And then I want the answer. So 12. Be careful. You didn't multiply feet together. You just added them. So you're going to have 12 feet.
When you multiply, you're doing square feet.
When you multiply is where you're going to get square feet, but be careful. I give you this. And I tell you that R is 3. This time I will do 3 meters. M for meters. About a yard. 39 inches. I want the volume. Now this is being triggered by the statement that if I multiply, I'm going to get square feet, so be careful. What is my formula for volume? There's one of them what you were doing in the quiz.
4/3 times R3.
Okay? You can say 4 over 3, or you can say 4/3. So it's 4 over 3 multiplied by pi. And if you say R3, how about R cubed? R to the 3rd power. Now you have to be careful there, because that means you're taking R times R times R. So if I have meters times meters times meters, I'm going to get cubic meters, or meters to the 3rd power. So you don't always get squared. So let's substitute. Next step. So it's formula, substitution, and then 3 times 3 times 3, and I left my meters out because I ran out of room. What can I do with that before I start multiplying? Look at the monitor if I'm in your way, and I know I'm in the way for a lot of you. Just look at the television monitor. There's one in the back of the room, there's one in the front, there's one on the side. What can I do right now that would be nice?
Change the 4/3.
I could change the 4/3 to a decimal, but there's something nicer. What now? I could make it 3 to the 3rd power, but something nicer than that.
Multiply into 27.
I don't like the 27.
Oh.
In a way it does. They are primes. Adrian's right about that. Okay, I'm going to show you something here that you're going to look at and you're going to go, I knew that. It is prime factored. What do you do if you have prime factoring?
Divide.
So I said, you're going to see that and say, I knew that. You can cancel, right? So the 3 goes out. You don't have to go to that silly decimal, 1.33333 on into the night. Instead, you have 9 here. 4 is 36. So this whole thing simplifies to 36 times 3.14 meters cubed. Now, if you want a rough estimate, just a rough estimate, this is like 3 times 36, which is 108. And it's going to come out more than that. I'm going to have to multiply and get what I suspect is at about 110. Lewis, you have your calculator. Will you multiply for me 36 times this? So 36 times 3.14. And let's see what I think it's going to be about 110, 113, somewhere in there. It is the 113.04. Thank you. Meters cubed. Now, that is not an exact answer. Reason? Pi is not what? Exactly 3.14. Now, Lewis, again, on your calculator, which is a scientific calculator, do you have a pi key? Otherwise, this symbol. On your calculator, do you see it? And if you do, you should be able to just press that key, and you should see 3.1415. What else is there? 2. So I have 3.14159, then a 2. And there's still more garbage to come. It goes forever. So the point I'm making, and maybe tweak that just a smidge, thank you. The longer we carry that out, the more accurate our answer.
But you just want us to focus on
I just want you to focus on 3.14. But I want you to understand that the 3.14 is sloppy. But for most work, it's okay.
sloppy's good sometimes.
Sloppy's good sometimes.
Sloppy Joes.
Oh, sloppy joes. And I'm sitting here thinking of lunch already. How unkind. Now, remember what the Babylonians did. Do we?
No.
Babylonians said the circumference, the distance around a circle to its diameter was what? What was their estimate? Going back what might be as much as 5,000 years ago. They said take any circle, take the distance around, put it over the diameter, and what were you going to get roughly? 3. Okay. That did not go well. What camera are we on, Ernie? We're on camera
Is this something
2.
you told us before?
Yes, it is. I thought I did. Ernie, on camera 1, will you go back over to the side there? And I'll just walk over to there in a moment, because we're just about finished up with this part. But if you'll go over to there and bring in that side. What I wanted to get is, I told you here, we wanted the circumference. And so the circumference was 2 pi r, but that could be written as pi d. So this could be written as pi times d. And if I divide both sides by d, look what I'm doing now. I'm dividing both sides by d. So that says c over d is pi. And that's what the Babylonians realized many, many centuries ago, millenniums ago. They said that take any circle, measure the distance around it, then measure the distance across. It will always be approximately 3. And of course, it took a few thousand years to realize it is not 3, it's 3.14159, etc. Now what we have to do, and I realize this is an abbreviated broadcast, I apologize for that, but we have a quiz we're going to do today in class.